more. Think of any number you want, like 1 lakh, 2 lakh, 3 lakh, 3 lakh, 5,096. These types of number. These are the numbers that are contained in number system. So this is a Venn diagram of number system. Interesting fact, this type of diagram is called a Venn diagram. So this diagram says that we have a very small set called natural number, a bigger set whole number. It is contained in integers, and then it is again contained in a bigger, larger set, that is rational number. So coming to our natural number, what are natural numbers? Natural numbers are the smallest set which we have learned from the very beginning, that are 1, 2, 3 and so on. They continues infinitely. Next set is whole number. Whole number is just 0 plus natural number. It contains 0 and all other natural numbers, 0, 1, 2, 3 and so on. Now our third set is integers, which basically contains our whole number and natural number both. That is, it contains 0, 1, 2, 3 and at the same time it also contains the negatives of this number, like -1, -2, -3 and so on. So now coming to the larger set, that is rational numbers. Rational numbers contain our all other sets like natural number, whole number and integers. But there are basically three forms of rational number. And the most important one is the first one, that is P by Q. And Q can never be 0 and P and Q are co-prime. But now what is this co-prime? Have you ever heard of this? Co-prime. Co-prime numbers are the numbers which are only divisible by 1, which are together only divisible by 1. For example, if I take 2 and 3, 2 is divisible by 1, 3 is divisible by 1 and there is no other number which can divide both. But at the same time, if I take example of 2 and 4, 2 is divisible by 1, 4 is divisible by 1. But these two numbers are also divisible by 2. So these numbers can never be co-prime. And these numbers are co-prime. Now the second form is terminating decimals. Terminating decimals are the decimals which terminates at some time, which ends at some time. Like 2.356. And it doesn't go after this. It stops at this one. Third is non-terminating decimals. Non-terminating repeating decimals. What does repeating means? It means that after some point the number is repeating itself. That is 2.34, 34, 34, 34 and it goes on continuously. It never ends. It never stops. That's why it's non-terminating. And 34, 34, 34 is repeating itself. That's why it is repeating decimals. Another set that is separate from rational numbers is irrational numbers, and it is denoted by QC. Here C means complement, that is different from rational numbers. These again have three forms. First one is the root 2, root 3, root 5. So basically form root P. The P can be any positive integer. But if I take example of root 4, is this an irrational number? No, because root 4 is nothing but 2 and 2 will be our rational number. So root 4, root 9, root 16, the number inside the root can never be a perfect square. So that's why these all are rational numbers and these are irrational numbers. The second form is non-terminating, non-repeating decimal. What it means, non-terminating, it never stops. Non-repeating, it never repeats itself. Like 2.341298397. number. In this chapter, we have in very first exercise questions like this, that we need to find rational numbers between other numbers. These are in three categories. The first one is rational numbers between two integers. For example, we are given 2 and 3 two integers, and we need to find like five rational numbers between them. So it's a very simple procedure. Think of a number larger than 5. You can take 6, 7, 8, but I prefer to take 10. Why? Because it's easier to multiply. So what I will do, I'll multiply it by 10 and divide by 10. You can see that if I cut this 10 by 10, we will again get 2. So this is an equivalent rational number to 2. Similarly, I'll multiply 10 and divide by 10. So this number will become 20 by 10 and it will be 30 by 10. So can I find five rational numbers between them? Obviously, what are these? 21 by 10, 22 by 10, 23 by 10, and I can write it till 29 by 10. So basically I have 9 rational numbers between it, and you have to write only 5. Similarly, if they say that you have to write 10 rational numbers. So you can multiply it by 20. Multiply and divide by 20 and 20, and then you will find like 19 to 18 rational numbers. So it's up to you that what number you are going to multiply it. Now the second form is rational number between same denominators. What it says that if I have rational numbers with same denominator, like 2 by 3 and 4 by 3. You can see this is the numerator and this is the denominator, and the denominators are same. Then again the procedure is same. You will multiply it by 10, divide by 10, multiply by 10, divide by 10. It becomes 20 by 30. It becomes 40 by 30. And I can easily write 5 rational numbers like 21 by 30, 22 by 30, and so on till 39 by 30. But now the problem arises that it says rationals with different denominators. For example, they are saying 2 by 3 and 4 by 5. So we can't multiply it by 10 and divide by 10. Okay? So what are we going to do? We are going to make the denominators same. And how are we going to do that? We are taking the LCM. The LCM of 3 and 5 will be 15. So it will become 10. And it will become 12. So our rational numbers become 10 by 15 and 12 by 15. So now you can see that this question is again of this type because the denominators are same. So again I will multiply it by 10, divide by 10, multiply by 10, divide by 10. It becomes 100 by 150. It becomes 120 by 150, and I can easily write 5 rational numbers between them. 101 by 150, 102 by 150, and so on till 119 by 150. Now coming to our next topic, that is decimals. What are decimals? If I write a number like 2.34, then this point is what is decimal. Now decimal are of two types, terminating and non-terminating. And non-terminating are further divided into two types, repeating and non-repeating. So what is terminating decimal? Terminating decimals are the decimals which ends after some points. Like for example 2.356. It ends at 6. It doesn't go further. So it's a terminating decimal. Now decimal non-terminating and repeating. What it says that 2.343434 and it goes on. Non-terminating means it will never end, and repeating means it will repeat a certain pattern again and again. You can see that 34 is repeating itself again and again. So these types of numbers are written as 2.34 bar, and this bar indicates that this 34 is repeating itself again and again infinite number of times. easy one. You need to write 8/7 as a decimal expansion. So basically what we are going to do is divide 8/7. It will be 7, 1. We will take a 0, and whenever we take a 0, we add a point to it. Then again 7 and 1, it will be 3. Adding 0, 28x 4, it will be 2. Again 0, 14, 2. If we see this will be a non-terminating, non-repeating decimal because it will go on infinitely, like 60, then it will be 56, it will be 40. It will go on and it will never end. So this is the method of finding the decimal expansion. The main question of this exercise is 2.4 bar. Okay, this is a very simple example. We need to write it in the form of P by Q. We need to transform it into the form of P by Q, that is rational number. How we are going to do that is a very... So let x is equals to 2.4 bar. 2.4 bar is what? 2.4444 and it goes on indefinitely. Now what are we going to do? Like we have one number behind the decimal. So we are going to multiply it by 10. Suppose we had two numbers, we will multiply it by 100. Three numbers, we will multiply it by 1000. So here there is only one number. So we will multiply it by 10. 10x. By multiplying it by 10, this one 4 will come forward and all the other 4 will remain as it is. It will be 24 by 0.4 bars. Now we are going to subtract them. This is equation number 1. This is equation number 2. We will subtract equation. We will do equation 1 minus equation 2. So 10x minus x is equals to 24.4 bar minus 2.4 bar. 10x minus x will be 9x and it will be 22. How is this possible? Because 24.4 bar, it will be 2.4 bar. All these 4 will be 0 and 24 minus 22 will be 22. So it will become 22. And now taking 9 on the other side, it will be 22 by 9. So here we can see that 2.4 bar can be written as 22 by 9. Now taking another example of this question. For example, 2.43 bar. You can notice that bar is only on 3, it is not on 4. So first thing, let x is equals to 2.43 bar. So the first thing is, see the number of digits behind the decimal. There are 2 digits, so we are going to multiply it by 100. It will be 100x and 2 digits will come forward, that is 243 and 3 bar will remain same. But can we minus this from this? Can we? Because this 4 will create a problem. So now we are going to do one more thing. We are going to bring this 4 with this 2. How? We are going to multiply it by 10. So it will be 10x and it will be 24.3 bar. So what have I done? I have multiplied it by the number of digits behind the decimal and the number of digits which are not under this bar. Always remember, not under this bar. So 10x. Now again we are subtracting these equations. It will be 90x and it will be 219.0. So x will be 219 by 90. So again we can see that we can write this number in the form of this. That is why the non-terminating repeating decimals are rational numbers. So now our next topic is irrational numbers. So I have told you before that irrational numbers are of the form root 2, root 3, root 5, root 7. And if I take an example of root 4, is it an irrational number? No, because it will be equals to 2 and 2 is a rational number. The never ends, and non-repeating means there is no pattern repeating itself. For example, 2.314976328 dot. So it is not terminating anywhere because it goes on indefinitely and no particular pattern is repeating again and again. So that's why it is a non-terminating, non-repeating decimal. The third one is pi. Pi is equals to 22 by 7, and when we divide 22 by 7, we will get 3.14. It will be a non-terminating, non-repeating decimal. That's why pi is also an irrational number. So the very first question we have is how to classify as rational or irrational number. For example, we are given a number 2 root 3. We need to classify it as rational or irrational. Then we will see this root part. Rational number multiplied by an irrational number will always give an irrational number. Taking another example, suppose we have 2 minus root 23 and plus root 23. What we will do, we will simplify it. We will simplify it as 2 minus under root 23 plus under root 23. We can cancel them out and it will be 2. Then it will be a rational number. So by seeing the question, it's not always possible that we can tell that it's an irrational or rational. We need to simplify it sometimes. For example, another question we have 3 pi by 2. We know 3 by 2 is a rational number, but I have told you before that pi is always an irrational number. So this whole number will be an irrational number. So now we will be doing the operations of irrational number. In our previous classes, we have done operations on rational numbers, integers and natural number. Operations are what? Addition, subtraction, multiplication and division. These are the operations on any type of number. So similarly, we are doing now operations on irrational numbers. So first of all, we will be doing addition and subtraction. It's quite complicated while we do it for irrational numbers. So take them as algebraic expression. For example, we have a question like this: 2 root 3 plus 3 root 2 plus 4 root 3 plus 9 root 2. We have a question like this. What we are going to do is, we can never add root 3 and root 2 because these are two different variables. Take them as an algebraic expression. X is equals to root 3 and y is equals to root 2. Okay, this is the part you will do it in your rough form. Okay, not in the question, in the rough form. So if I take x as root 3, the question will become 2x plus 3y plus 4x plus 9y. Right? We know that in algebraic expression, x cannot be added to the y. X can be added to x and y can be added to y. So we will combine these two terms, 2x plus 4x and 3y plus 9y. Now we can add them as 2x plus 4x is 6x, 3y plus 9y is 12y. Now again substituting these values here again, you will get 6 root 3 plus 12 root 2. Okay, this is the part which you will do in your mind only. You can't write this in the question. So you need to focus that root 3 can be added to root 3 only and root 2 can be added to root 2 only. We can't add root 3 and root 2 terms. Similarly, if I have a minus in place of plus, so suppose we have a minus here and a minus here. Okay, so the question will change accordingly. Like this plus will change into the minuses and 2x will be subtracted from minus 4x. 3y and 9y will be like this. So we will change the coefficients accordingly. Like 2x minus 4x will be minus 2x, minus 3y plus 9y will be 6y, and the question will become this. So in addition and subtraction, the procedure is same. You need to remember that root 3 can be added to root 3. Only the like terms can can be added. For example, we can't add root 3 and root 5. We cannot add them, so the answer will be as it is. Okay? Now our next topic is multiplication. How are we going to multiply the irrational numbers? For example, we have 2 root 2 multiplied 4 root 3. Okay? What we are going to do is the number on the outside of the root will be multiplied with each other, and the numbers in the inside of root will be multiplied to each other. We can multiply different unlike irrational numbers, but we cannot add or subtract them. So the answer will be 2 into 4 and root 2 into root 3. Root 2 into 4 will be 8. Root 2 and root 3 will become root 2 into 3. We can take root outside and it will become 8 root 6. So we can multiply unlike irrational numbers, but we cannot add or subtract. So the other operation we all know is division. Okay, in integers, in natural numbers, in rational numbers, we can divide each other. But there is no such thing as dividing in irrational number. It will be given a name called rationalization. It's a new concept and there is no term as division of irrational number. Now for example, we have a number root 7 in the denominator. So this root 7, whenever there is a irrational number in the denominator, it is a rationalizing factor. It is called rationalizing factor. And the procedure of rationalization is, what we will do, we will have to remove this root 7 from the denominator. So what we are going to do is, we are going to multiply it by root 7 and again divide it by root 7. Now 1 into root 7 will be root 7 and root 7 into root 7 will be root 49. And root 49 is nothing but 7 itself. So this number can be written as this, and this procedure is called rationalizing. But now there is one more type of question. Suppose we have 2 upon root 3 minus root 4. Okay, there are 2 irrational numbers in the denominator. So we know that this is the rationalizing factor and we need to eliminate it. But if I multiply root 3 minus root 4 by root 3 minus root 4, this number will not get eliminated. So what I'm going to do is, I'm going to change the sign of this factor. We will multiply and divide it by the addition of these numbers. Because if I take minus over here, the root part will not get eliminated. So now solving this part, we will do 2 root 3 plus root 4 and it will be root 3 minus root 4, root 3 plus root 4. We can see that these numbers are in the identity form. We have an identity a minus b, a plus b equals to a square minus b square. So we will apply this identity over here. It will become 2 root 3 plus root 4 root 3 square minus root 4 square. So it will become 2 root 3 plus root 4 and the root square part will cut the roots and it will become 3 minus 4. So it will become 2 root 3 plus root 4 upon minus 1, and we can also write this minus 1 on the numerator side. So we can write it like this also. So this is a very simple procedure, but we need to keep practicing it because you will get many mistakes while multiplying these irrational parts. So now we will be representing the irrational numbers on number line. We know how to represent them, the rational numbers, the integers and natural numbers on the number line. Similarly, we are going to do the same for the irrational number, but the procedure is little different. Suppose we need to represent root 2 on number line. So what are we going to do is, we will draw a number line 0, 1, 2, 3, and -1, -2, -3, 5. Okay, we have a number line like this. Root 2. We can write root 2 as under root 1 plus 1. Right? It will be 1 plus 1, 2, and we will get root 2. Now we can write it as 1 square plus 1 square, because 1 square will be 1 again and 1 square will be 1. So we will get root 2. So now looking at it, root 2 equals to under root 1 square plus 1 square. It is the form of a Pythagoras theorem. You can see that it will be our perpendicular, it will be our base, and it is our hypotenuse. Right? Pythagoras theorem is x squared equals to e squared plus b squared. So we are going to take a base of 1 unit. 1 unit. So it is a base of 1 unit from 0 to 1. And then we will draw a perpendicular of the same 1 unit on 1. Right? It will be our base and it will be our perpendicular. Now we will join this point with our 0. What we are going to do is we are going to take a compass and measure it like this, and we will draw an arc like this with a compass. Right? So now this point what we get is our root 2, and this is also our root. This is 1, this is 1, and this is root 2. And satisfying the Pythagoras theorem, we make an arc of this root 2 and we will get root 2 as our irrational number. In the same diagram, we can also draw the graph of root 3. Okay, root 3 can be written as root 2 square plus 1 square. Try to solve it. It will be under root 2 plus 1 and we will get root 3 again. So root 3 can be written as this. So we will take root 2 as the base and 1 as a perpendicular. We can say that where is root 2? Root 2 is here. Right? This is our root 2. And we will draw 1 unit perpendicular to it. We will join it with the origin and take opening the compass of this much unit, we will draw an arc. And this point will be our root 3. If I continue in this pattern like root 4, root 5, root 6, we can draw them on this, like this, and it will cut like this. Then this, it will cut like this. We can draw it many times and we will get a square root spiral. Square root spiral. There is also another way to represent irrational number on number line, because by the square root spiral we cannot represent the numbers like 9.3. Right? These are also an irrational number, and on that number line by the square root spiral we cannot represent them on number line. So there is another method which can be applied to these types of number also. Okay? So what we are going to do, suppose we need to make a graph number line of 3.6 under. Okay, this is our question. Okay? I am going to draw a line of 3.6 centimeter. Okay, 3.6 centimeter, and I will add 1 more centimeter to it. So the whole line will become of 4.6 centimeters. Okay. Now I am going to draw the perpendicular bisector of this line. How it's going to be made? Open the compass more than half of it. Make an arc here and make an arc here. From this point, A, B, C. From this C point, we are going to make an arc of the same length, and we are going to join them. Now this point is the center of this line. Now taking this as a radius, we will draw a semicircle. Okay? Now we will join this B to this semicircle. So what we have done here is taking AB as 3.6 centimeter, adding one more centimeter to it. It will become 4.6 centimeter. We will draw a perpendicular bisector of this line and we will join them and we will get the center of this line. Then we will draw a semicircle and join this B point to this semicircle. Now taking further, we know that this is 1 centimeter. So we will name this point as 0. This C will be our 1. And then taking one more centimeter, we will get 2. One more unit, we will get 3. Now we will open our compass to this much length. And from this B, we will draw an arc like this. Right? And now this point will be our under root 3.6. Okay? What we have done in square root spiral, we can also do those type of questions through this method also. Right? We can also draw root 2, root 3, root 7, but also we can write the decimal roots also. So I hope you might get this number line of irrational numbers. So students, keep practicing. Thank you.